Let's solve some equations here. And I'm not talking your basic one-step or two-step equations, or even equations with the variable on both sides. We're talking about rational equations. Okay, these bad boys are fun. The reason why they're fun is because they can be challenging. I know some of you don't like the challenge, but hey, when you answer these things and you get it right, it's a good feeling. So let's step up to the challenge today here. So I have an example of a rational expression here. 5 over x plus 3 equals 3 over x. Okay? First thing I want to, when we get through and we solve, I can't have any extraneous solutions is what we call this term right here, extraneous solutions. It's basically if I would solve and I get a solution that makes the denominator 0, I can't use that because it's an extraneous solution. So if I would go through and I would solve and I would get x to be negative 3 or 0 here, which it's not, okay, but if it did, it would make my denominator 0, but that doesn't work, okay, because I can't divide by 0. Right? If I ever try to type something divided by 0, it does not work. So we can't have any extraneous solutions. So we are always going to state those in the end if we have them. But we got to go through and solve before we can check to see if it is extraneous. So first thing, I got a fraction equal to a fraction here. Okay? Most of you know that as a proportion, right? So in this case, I might want to just take the cross product of these two fractions. So I'm going to take 5 times x, which is 5x, equals x plus 3 times 3. Well, remember, you got to do that 3 times the entire x plus 3, so it's really your distributive property. So you got a 3x plus 9, right? 3 times x and 3 times 3. And now you're just your two-step equation. So subtract my 3x over, and we have 2x equals 9, and divide by 2 to give us x equals, well, 9 over 2 is fine, or 4.5, or 4.5, however you would like to write this. Yeah. And if I go back, I should check to see if it's extraneous, which means if I plugged in 4.5 in for x here, would that make my denominator 0? No, it doesn't, so it's not extraneous, which means this is my solution. That works. So we're good to go. Let's take a look at another case. Here I can't just take the cross product, right? Because I have a fraction plus a fraction on the left side, so I have two fractions. But if you notice, I have a common denominator. So if you have that common denominator, you might want to just make it into one fraction. So let's do that. Since it's common, I can put it all over 1x minus 1 here. And I'm just taking 3x plus 6x minus 9, and a 3x plus a 6x is a 9x, and that's minus 9, and that equals 6. Okay, you might be thinking, well, I can't do the cross product here because I don't have a fraction on the right side. Well, you can make it a fraction, can't you? You can put anything over 1. So once again, I can just take the cross product. It's probably the easiest way to do it if you're able to do it. So let's go ahead and take the cross product here. So I got 9x minus 9 times 1. Well, anything times 1 is just itself. And that equals 6 times x minus 1. And remember to distribute. So it's a 6x minus a 6. Right? You got to distribute to both. Okay, same thing. Now just a little bit of algebra. So subtract your 6x over, and you're left with 3x minus 9 equals negative 6. Add your 9 over, and you have 3x equals 3, and divide by 3 to get x by itself, so x equals 1. So is that my answer? I should better check to see if it's an extraneous solution. So that means I got to plug my solution back in. If I put a 1 in for x, what do we notice? 1 minus 1 is 0, isn't it? So that makes my denominator 0 in both these cases. And I cannot divide by a 0. So this does not work. There is no solution here. But I should state that I do have an extraneous solution of 1, don't I? Okay, so there is no solution, but there is an extraneous solution of 1, because 1 works, but if I plug a 1 in, I end up dividing by 0, which doesn't make sense. I can't do that. So essentially there's no solution, but we solved and we got 1, and then made our denominator 0, so we call it an extraneous solution. So you always got to check to see if it's extraneous or not. looking at the next example, okay, I don't have a common denominator here. I got a b minus 2, and I don't have a denominator there. And now I got a denominator on this side, don't I? Okay, you could get a common denominator, but that's really not going to help you all that much. It's going to make things pretty complicated. Okay, so my main objective is to get rid of the denominators, okay? Because if I look at these last two examples, right here, I have no denominators, right? 9x minus 9 equals 6x minus 6. Look at this last one. After I cross product, I had no denominators, okay? So if I get something like this and I can't just simply take the cross product, we want to try to get rid of the denominators. Well, to get rid of denominators, you want to multiply by, okay? So the first thing you want to do is find what is the common denominator between all these guys, okay? What is the least common denominator, the LCD? Call it the LCD, right? The least common denominator. Well, in this case, I got a b minus 2. There's really a 1. We don't need to worry about that on that guy. And a b plus 2. So that would be my least common denominator. A b minus 2 times a b plus 2. Kind of like from our last section that we had. You basically just multiply the denominators to figure out your common one. So we're going to use this now. You want to multiply both sides by this. And that'll cancel out your denominators. And you'll see that happen here. So that's what we're going to do. I'm going to take a b minus 2 times a b plus 2 times both sides. B minus 2 times a b plus 2 times both sides. Okay? So let's look at the left side here. Well, if you look at it, I have a minus sign right here, which means I have to distribute this whole thing right here. So I'm going to take this times my first fraction here. Well, if you notice, the b minus 2's cancel. Okay, so the b minus 2's cancel. So that's gone, that's gone. And you just left with a b plus 2 times a 2b minus 5. Well, go through your FOIL. So b, I better write this out here so you see it, times a 2b plus minus 5. So you're left with 2b squared. And b times negative 5, negative 5b. 2 times 2b plus 4b. And 2 times negative 5 for minus 10. So you have 2b squared minus 5b plus, oh, I screwed that up. Should be plus 4b, right? 4b minus 10. And we combine our negative 5b and our 4b to get a negative b plus 10. Okay, so that's how I distributed the first one. Well, now I got to distribute to the next guy here. So I got to use both these again. Well, nothing cancels with the denominator, right? So it's just 2 times all that, isn't that? So I really have, we got a minus sign here, so minus 2 times all that, b minus 2 times b plus 2. So let's go ahead and let's distribute. I'm going to do the FOIL over here first. Doesn't really matter what you do because you're just multiplying. So I got b squared, and I got a 2b, whoa, and then I'm going to have a negative 2b, so those cancel. And then in the end, I'm going to end with negative 2 times 2 for a negative 4. Okay, and I'm still multiplying this negative 2 by that. So now I distribute the negative 2, and I get negative 2b squared plus 8. So I need to add that on the end of this guy right here. So now I got it. Well, I can combine these, can't I? So a 2b squared minus a 2b squared is gone. I still have a negative b plus 8 plus 10 gives me a plus 18. So that's my whole left side now. I just simplified that left side. Kind of confusing, isn't it? Okay, this next side should be a little bit easier. If I go up here, looking at the right side, a b plus 2 cancels with a b plus 2 there. So I just have a 3 times a b minus 2. Well, 3 times b and 3 times negative 2, which is negative 6. So that's going to equal a 3b minus a 6. So it takes a little bit of work, doesn't it? Now we get our b to one side, so we add a b, and we're left with 18 equals 4b minus 6. Add our 6 over, and we got 24 equals 4b, and divide by 4. So b equals 6. There we go. And now I got to see if it's extraneous or not, so I go back up. if I plugged in a 6 for b, would that make my denominator 0? 6, 6. No, it doesn't, so I know it's a solution. So there are no extraneous solutions. All I know is that b equals 6. So it takes a little bit of work. Okay, let's do another one of these. So same thing here. But it's good to factor before you do anything else. Okay, so I'm going to change this 3n plus 6. I'm going to factor out a 3, and I'm left with an n plus 2. And I'm going to factor this 5n plus 10, so I'm going to factor out a 5. So we got an n plus 2. And then I got a 5 on the other side over there in the denominator. So our LCD, our least common denominator, would be, let's see, I got a 3. I got n plus 2's, so n plus 2. And I also have 5's, don't I? So we're multiplying 3 times 5 times n plus 2. And if I simplify that, I got a 15 times an n plus 2. So that's what we're going to multiply both sides by. And the reason why we do that, because it'll help cancel our denominators. So I'm going to take this left side times a 15 times an n plus 2. And I'm going to take the right side times a 15 times an n plus 2. Oh yeah. Let's take a look and see what happens here. Well, the left side. If I distribute this to this first one, yeah, I distribute it to that first one. If I look, my n plus 2's cancel. So this is going to cancel with this n plus 2. And a 15 and a 3 goes into both. So it's really, that's gone, and I'm left with just a 5, aren't I, up top here? So it looks like the n plus 2's cancel. And also, a 3 goes into both my 15 and my 3. So that's gone. And 3 goes into there 5 times. So really, I'm just taking my 5 times my n up top, aren't I? So I got a 5n. Okay? Now I also need to distribute that 15 times n plus 2 to the next term. Yeah, so we need, well, let's cancel things. So if we look, n plus 2's cancel again. And a 5 goes into both these, so that's gone. 5 goes into here 3 times. So it's really a 3 times a negative n. So a negative 3n. And all my denominators are canceled, aren't they? That's our purpose. That's why we do that. And that's going to equal, well, let's cancel over here. So 5 and a 15, 5 goes into both. So this becomes a 3, because 5 goes in there 3 times. Now we got 2 times a 3 times an n plus 2. Well, 2 times 3 is 6. And 6 times an n plus 2 is a 6n plus 12. And now I can go through and solve. Get my n's to one side. Well, this is really a 2n. Okay, and either way, I'm going to get my n's over here. So I'm going to minus a 6n minus a 6n. So we got a negative 4n equals 12. N divided by negative 4. N equals negative 3. And I want to check and see if it's extraneous. So I need to plug it back into my original equation. Well, if I plug a negative 3 in here, negative 3 times 3 is negative 9. So that's not going to make that 0. Plug in a negative 3 over here. 5 times negative 3 is negative 15, so that won't be 0. So we're good. No extraneous solutions. I know that n equals negative 3. Okay, so you just need to multiply both sides by the least common denominator. And it takes a little bit of work. Try not to lose track of your work. That's the hardest part. Okay? We might have some questions on this. That's okay. We're not going to worry about this story problem for now. So you can skip ahead. I'm going to go through it just so it's on the video. But you can skip ahead and we'll worry about this later. But it's very similar to what we've done before. If you look, we got a bus, 2 buses leaving the train station. One leaves 20 minutes later than the other. First bus is going 50 miles an hour. second bus is going 60 miles an hour. It says how long will it take the second bus to pass the first bus? So if we think about it, bus 1, okay, its distance is going to be the same as bus 2's distance in the end, right? Because they're traveling the same distance, aren't they? Well, to solve for distance, we use distance equals rate times time. And we know the rates of both. So in this case, bus 1 is going 50 miles an hour. And bus 2 is going 60 miles an hour. We're trying to find the second bus's time, so I'm going to leave that as t. But I need to adjust bus 1, the time for bus 1. Okay, well, it left 20 minutes before the other one. So in the end, when I set these distances equal, bus 1 actually traveled an extra 20 minutes, didn't it? So instead of having t, time is going to be t plus 20 for bus 1, which means its distance equation will be 50 times, well, I'm replacing t with t plus 20, aren't I? So I'm going to keep it in parentheses. And we just talked that we're going to set these two distances equal to each other, right? Because essentially they traveled the same distance once bus 2 passes bus 1, right? Because here's the station. Bus 1 leaves 20 minutes before, and then bus 2 leaves. And eventually it's going faster, so pretty soon, right, they travel the same distance. Kind of an ugly picture there. So I'm going to set these equal to each other. So 50, I'm going to distribute here, 50 times t plus 50 times 20, n equals 60 t. Well, I screwed up already, didn't I? Because time is always, right now it's in hours, isn't it? It's in hours. So I can't add 20 here, because that's not 20 hours. So I got to say plus 1/3. Plus 1/3. Because it's 20 minutes is 1/3 of an hour, isn't it? 20 over 60 simplifies to 1/3. So that's going to change this right here. It's really going to be plus 50 over 3. There we go. That looks better. So now we get our t's to one side. So subtract 50t. And we got 50 over 3 equals 10t. And we're going to need to divide by 10. And this is very similar to what we did before. So it's really 50 over 3 divided by 10, which is the same thing as multiplying by the reciprocal. Right? 50 over 3 divided by 10. Multiply by the reciprocal. So it's 50 over 30, which is 5/3. So t is 1 2/3 hours. Or in that case, 1 hour and 40 minutes it takes the second bus to pass the first. Yeah. So essentially, it's going to take a little work, but get the time in hours because that's what our rates are in. So don't get tricked by the 20 minutes and then go through your algebra in the end when you set them equal. There's your assignment. Good luck. Deuces.